Hello, my name is Raquel Requena and I will present my research study performed during a short-term scientific mission of Cost Action FP1405 entitled Sequential Subcritical Water Extraction and Acid Hydrolysis for Obtaining Cellulose Nanocrystals and Silans from Rice Husk to be used as reinforcing and active agents in food packaging materials. The collaboration between Sweden and Spain within the short-term scientific mission was conducted from the 1st of September to the last of November. The home institution, the Institute of Food Engineering for Development at Universitat Politècnica de Valencia, where I am doing my PhD, have an important research group focused on the development of active and biodegradable materials for food packaging application. The host institution was the Glycosides Division together with the Wallenberg Study Center at KTH Royal Institute of Technology. Both are experts in the biotechnological exploitation of bioactive polysaccharides from food byproducts using environmental friendly processes and their valorization into functional materials. My supervisor during the short-term scientific mission was the Professor Francisco Vilaplana, Principal Investigator at the Division of Glycosides at KTH Biotechnology. The raw material for the short-term scientific mission was rice husk, provided by DAXA, a leading company in the production of rice. Rice husk is a byproduct from the food industry with a hemicellulose fraction made of substituted arabinoxylan, which breakdown leads to cell oligomers with food, medical, and pharmaceutical application. In addition, another way to valorize rice husk involves the exploitation of his high cellulose content for producing cellulose nanocrystals and fibers. Therefore, the main objective of the short-term scientific mission was the integral valorization of rice husk through two different processes. On the one hand, the traditional alkaline extraction followed by the lignification and acid hydrolysis, and on the other hand, a sequential subcritical water extraction followed by the lignification and acid hydrolysis. Since the subcritical water extraction is a promising green method for the isolation of hemicellulose fractions with preserved molecular functionalities and high molecular weight, unlike the traditional alkali treatments. In this way, it is possible to fractionate polymeric hemicelluloses to be used as antimicrobial and antioxidant materials, and on the other hand, obtain CNC to be used as reinforcing materials to develop food packaging materials. Thus, the traditional approach commonly used to produce CNC based on consecutive alkaline extractions, bleaching, and finally acid hydrolysis was compared to the subcritical water extraction followed by the corresponding bleachings and acid hydrolysis. As an alternative approach to obtain CNC, since subcritical water extraction preserves the inherent functionality of hemicelluloses obtained during the first part of the process, unlike the alkali treatments. This was the working plan carried out during the short-term scientific mission. First, the rice husk was milled using a Willy mill to reduce the particle size to 20 ms, thus improving the extraction process. Then, the extraction with subcritical water at 160 degrees was carried out at different times in order to optimize the extraction time. The resulting residue was used to continue with the bleaching and acid hydrolysis, whereas the extracts were freeze-dried for subsequent characterization. On the other hand, the milled rice husk was also submitted to 3 consecutive alkaline extractions, and the resulting residue was also used to continue with the bleaching and acid hydrolysis. After that, the CNC were purified by successive centrifugation and dialyzed during 1 week previously to the sonication. In the same way, the extracts resulting from the alkaline extractions were freeze-dried for subsequent characterization of the composition and molecular structure by high-performance analytic chromatography with pulse and perimetric detection, and gas chromatography mass spectrometry. In addition, the different materials obtained in both traditional and alternative process were characterized using different techniques such as SEM to observe the microstructure, TGA to determine the thermal stability, Claxon binding determination, Soselec extraction to determine the total amount of extractives in water and ethanol, FTR to characterize morphologically the materials with respect to changes in the functional groups, AFM to determine the CNC size distribution, and XRD to analyze the crystallinity. After the different treatments, the visual aspect of the samples show that the more aggressive condition in the alkali treatment led to residues with less amorphous components, lighter color. For this reason, the bleaching treatment was more effective in alkali residue, thus obtaining more bleached materials that is with less naming content. The yield for the first alkali treatment was significantly different to the second and the third one, which can be explained by the complete removal of extractives during this first treatment. The extras were dialyzed in order to remove the remaining reagent previously to the freeze-dried state, which could explain that the yields for the first alkali treatment do not reach 100%. On the other hand, the yield of the subcritical water extraction in terms of extract obtained after 60 minutes was considerably higher, also taking into account the environmental effect of both extraction methods are quite different, being the subcritical water extraction more environmental friendly. Since the subcritical water extraction conditions are water at 160 degrees for 60 minutes, whereas the alkali extraction conditions are 3 consecutive extractions with sodium hydroxide 4.5% at 80 degrees for 2 hours each one. Regarding the bleaching treatments, the yields in terms of residue was higher for the traditional approach compared to the alternative method, since the starting material coming from the alkali treatment had less amorphous components due to their higher effectivity removing these components compared to the subcritical water extraction. After 5 minutes, the extract of the subcritical water extraction contains mainly glucose, probably due to the presence of starch residues coming from the rice husking process. But, as time progresses, the silane content in the extracts increases as a result of the extraction of hemicelluloses, reaching a silane content of 80% after 60 minutes. Likewise, the silane content was higher in the second and the third alkaline extraction compared to the first one. However, the amount of silane extracted was always lower in the extracts coming from the subcritical water extraction. During the alkaline and bleaching treatments, the amorphous component and most of lignin were removed, thus opening the cell wall and liberating the cellulosic fibers as shown on the same micrograms. However, the surface of the bleached materials coming from the subcritical water residues show the presence of some fibers that keep together due to the lower efficiency of the subcritical water extraction to remove the amorphous component compared to the alkali treatment. The thermal stability analysis also validated the extraction of the amorphous component during the alkaline and bleaching treatments, since the main degradation peaks show smaller solvers on the DTG curves. This change was less noticeable in the subcritical water extraction residue due to the Miller condition of this extraction process. The materials resulting from the different treatments degrading within a narrower temperature range and show better thermal stability than the raw material. The hydrolysis reaction gave rise to more thermosensitive samples, being the CNC coming from the traditional approach more thermostable than those coming from the subcritical water extraction. Regarding the FTR analysis, the alkaline and bleached samples show a higher peak in the region related to the OH vibration due to an increase in the hydrogen bond strength, because of the removal of the amorphous components. This chemical structure change was not noticed after the subcritical water extraction due to the presence of some remaining amorphous component, since the subcritical water extraction conditions are milder than in the alkaline treatment. The peaks related to the hemicellulose and the lignin were disappearing along the conversion from macro to nano dimension. XRD analysis also demonstrated the progressive removal of the amorphous component along this conversion, since the crystallinity increased progressively, which was more noticeable for the traditional approach. To sum up, these were the preliminary conclusions obtained during the short-term scientific mission. Subcritical water extraction gave rise to higher yield of hemicelluloses than the alkaline extraction. Moreover, the environmental effects of both extraction methods are quite different, being the subcritical water extraction more environmental friendly. The bleaching treatment was more effective on the alkaline residue than on the subcritical water extraction residue, since the alkaline residue had less amorphous component due to the more aggressive condition of this process. The bleaching materials coming from the alkaline extraction were more pure than the bleaching materials coming from the subcritical water extraction. The thermal stability analysis also validated the extraction of the amorphous component during the alkaline and bleaching treatments, since the main degradation peak showed a smaller shoulder effect that was less noticeable in the subcritical water extraction residue due to the milder condition of this process. The hydrolysis reaction gave rise to more thermosensitive samples, being the CNC coming from the traditional approach more thermostable than those coming from the subcritical water extraction. FTR and XRD analysis also demonstrated the progressive removal of the amorphous compound along the conversion from macro to nano dimension, since the crystallinity increased progressively, which was more noticeable for the traditional approach. Finally, underline the further work. On the one hand, study the potential antimicrobial and antioxidant activity of the hemicelluloses extracted from the rice husk through subcritical water extraction, since it has been demonstrated as a method to preserve their functionality. In order to incorporate these hemicelluloses in biodegradable films to develop antimicrobial and/or antioxidant materials for food packaging application. And on the other hand, incorporate the CNC obtained through both extraction processes in biodegradable films in order to improve their functional properties as packaging materials, since CNC has been previously described as reinforcing material. Finally, I would like to thank the Professor Francisco Villaplana for inviting me to be part of his research group during this amazing period, and the support of the Cost Action FP1405 Actinpak, who made possible this interesting research stage.